Howdy, everyone. We are working on section 4.2 today. This is a system of linear equations, but a little different than what we've been doing. We've been working with two variables and two equations. Today, we're going to make a change and go three variables, three equations. We're going to talk about the geometry of those systems of equations and how we can see the various answers that are possible. And we're going to do the elimination method once again with the three variables. And some of them may have missing terms, so we may not have equations that have all three, I'm just going to make up a number there, all three variables in it. We could see some with two, and that'll make it more fun. All right, a solution of an equation in three variables. 2x plus 3y minus z equals 4 as an example is called an ordered triple, and it is written out as an x, comma, y, comma, z. We're used to an ordered pair for a coordinate pair on the xy axis, and we knew that was our x value. This was our y value, and if I plotted out 3, 1, I would have been somewhere over here. Well, there also is a 3D way to graph things, and you get your x-axis, your y-axis, and this turns into a z-axis. So we can talk about 3D space. The graph of a linear equation with three variables is a plane, not a line. So it defines a plane situation. And you can see by the demonstrations here below the various ways we can get answers. So if I have three planes, they can intersect in one common point. We also can have three planes oriented such that they intersect in a line. We could have all three planes just be like boom, 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 all one on top of each other. And in that case, they share oodles of points, so infinite solutions on that one. This letter D is showing no points in common. So you're seeing floating planes that are running parallel. So we have parallel lines. We can have parallel planes that never intersect. For E, we can see that there is a vertical plane and two horizontal planes that are parallel. And this would create then no common points to all three planes at the same time. So that's why there's no solution on this one. On F, there are also no solutions. And on G, they're showing two planes that are like on top of each other. They're sharing all points. And then you've got a third plane that's parallel, so no solution. So really on these three situations, there are no solutions. When you're solving three variables, I think it's nice to get a routine, an algorithm kind of going. You will start by eliminating a variable. You'll use the elimination method, and you'll choose two of the original equations. You can work those two equations together, and you'll eliminate one of the three variables. That's going to leave you with a two variable equation. And then I'll do that again. I'll choose another two equations. So maybe the first time I chose equation 1 and 2, maybe the second time I'll choose equations 2 and 3. And I'm going to eliminate a variable from 2 and 3 added together. So I'm back to a two variable equation as a result of that work. Now, I've just generated two new equations. I sometimes label them number 4 and number 5. And then what I'm going to do, I want to eliminate the same variable when I'm working those two systems together, so that when these come together, I now have equations 4 and 5 that maybe have x and y and an x and a y together. And I can use systems of equations with two variables, which we're very familiar with, to get myself down to one variable. Sometimes I think about that as equation 6. Once I get to that bottom part, then I'm going to work myself back up and take this variable, plug it in either to 4 or to 5, find one of these two, and then I'll take those two variables and work my way back up into equations 1, 2, or 3. So I kind of think of it as climbing down, going down into equations 4, 5, and 6. And then once I get to the bottom, then I come back up and I have all my answers. Some of you have done this before. If you were in regular Algebra 2, you've probably done it before. If you were in the other, maybe Algebra 2 Essentials, this may be something new for you, but I think you'll like it. They're always kind of fun. So example 1, you notice that we have 3 equations and they've been labeled out for us, 1, 2, and 3. They also each contain 3 variables. So sometimes I think this actually makes it a little bit easier. Let's go after, do we want to eliminate y's? We can eliminate y's. Let's do it. All right, so I'm going to, and I'm just going to make a note to myself. Oops, that didn't write very well. Eliminate y. I'm going to use equation 1 with equation 2. And so I'm just going to write equation 1 down. And I'm going to copy equation 2. Make sure you copy correct because that can really mess you up. All right. I'm going to add them together because what I'm after is taking advantage of the positive negative on the y for elimination. All right. Adding them together, we get 2x's not quite, plus 3z equals 4. I think of this as a new equation. Since I've already have 3 equations, I'm going to call this one equation 4. I need to find another set of 2 equations and eliminate y again. I used equations 1 and 2 in the beginning, and now I'm going to use, I was trying to see my notes here, just so it kind of follows along. I'm going to use 2 and 3 this time. So 2 and 3. Equation 2, x minus y plus 2z equals 2. And then equation 3 was negative x plus 2y minus z equals 1. Now, we are not quite as fortunate this go round. Let me get my highlighter here. Why was that not? Because when I look at the y's, they don't naturally eliminate this go round. So let's do some manipulation. We know we can multiply by a variable. So I think I will multiply this by a 2. Okay, so that's going to get modified, giving me 2x minus 2y plus 4z equals 4. Equation 3 can just be recopied because it is in a great format for us. All right, on with elimination method. I get an x, I get 0 y's, and 3z equals, add them together, and I got 5. Now, I like to call this equation 5 because I generated a new equation, so I keep track of them. So we've taken 2 different systems, eliminated the same variable y from both. Now what you'll notice is that we have 2 new equations, equations 4 and 5, that just have 2 variables. So we are going to bring them together and eliminate one of the variables. So I'm just going to write them down side by side, make it a little easier for us to do a comparison. Oh, I'm liking what I see. I hope you do too. So I am working equations 4 and 5 together, and I'm going to eliminate, what should we eliminate? Z? Yeah, I think so. Z is looking really good. All I need to do is make a negative out of that, right? So I'm going to multiply the second line by negative. And I modified it right then and there. You may want to write your stuff all over again to give you a better note progression. Now let's add vertically. So I'm going to get 2 minus 1x equals 1x. The z's are gone, and I get 4 minus 5 equals a negative 1. We got one of our answers. This is fantastic. I think of this as kind of equation 6, and I've hit the bottom of the well, and now I need to climb myself back up and out of the well. So my next step is I'm going to find a variable. I'm going to go find a variable. And I'm going to use either equation 4 or 5 because they are just a 2-variable equation. Using either, sorry, this just isn't writing exactly smoothly today, 4 and 5. Using 4 or 5 would be better, wouldn't it? It's not English class, but a little bit is, isn't it? Which one do you like best, 4 or 5? Well, we have x. I'm choosing 5. I'm going with 5. Mainly because it was just a single x, so I substitute -1 in there plus 3z equals 5. And add 1 over, I get 3z equals, adding that 1 gets us a 6. Z turns out to be 2. Fantastic. Now we have 2 variables. And I climb back up a little bit higher, up out of the well. I'm now up to equations 1, 2, or 3. Find variable using number 1, number 2, or 3. Your choice. So I got to take and scan back up and see which one I'm in love with. I'm loving number 1. X plus Y plus Z equals 2, mainly because I can remember it writing it down. So I'm going to choose, going into equation number 1, X plus Y plus Z was equal to 3. And then I did all that talking, kind of forgot. No, it's equal to 2. Okay, equals 2. But we know x and we know z, so substitute in. X is -1 plus our y, which we don't know. Z is 2 equals 2. So I end up with y plus 1 equals 2. Subtract 1 and we get y equals 1. Success! Maybe this is your first 3x3 for solving. Alrighty, x is -1. Y is 1, Z is 2. What do we call that? We call that our ordered triple, and it is our solution. That is the single point that these 3 equations or these 3 lines or planes have in common. I should say planes. Oh, not what I wanted. I wanted to back up and say, back up again, back up again. We had this scenario going on. The 3 planes collide into that one single point, which was located at -1, 1, 2. All right. Looks like what do we have? Oh, we do just do the one example, don't we? Now, homework-wise, there's only 4 problems because, as you can see, they take a little bit of time to solve. Verify before you start them that you have all x's in one column, the y's falling in a column, and the z's falling in the same column there, right? Because you've got to have that alignment. And give it a try. I like them. I think they're kind of like a puzzle, so enjoy.